All right, let's do problem 33 on page 146. I'll read it. It says a force of 40 Newton accelerates a 5 kilogram block at 6 meters per second squared along a horizontal surface. A, how large is the frictional force? And B, what is the coefficient of friction? So we have a horizontal rough surface. We've got some kind of block, like a wooden block. And we've got an applied force of 40 newtons. Okay? And it says the acceleration is 6 meters per second squared. Find A, the friction force, and B, the coefficient of friction. And this is kinetic friction. Solve. So this is step one. I read the problem, drew a picture of it, wrote out what was given. Okay, so now I'm going to do step two. Let's draw a free body diagram. What forces are acting on this? Well, of course, I've got the 40 Newton applied force. I've got friction. I mean, that's what I'm trying to find. I drew that a little too big. Gravity's pulling it down. I'm going to write that as mg. And I've got a normal force. And, oh, and I forgot to put the mass. The mass is 5 kilograms. So here's my free body diagram. I'm going to make this the x and y direction. There's step 3, done. Step 4, sum the forces in the x direction equals ma in the x direction. Do you see how I write that every time? Then I look at my free body diagram. Let's look in the x direction. There's only two forces. The applied force minus, because it's dragging the other way, equals ma. There is acceleration. Solve for the unknown. Force of friction equals, well, let's see. Let's move friction over here and ma over there. So it'd be the applied force minus ma. You see that algebraic step? I did in multiple steps. Then I just plug this in. The applied force is 40 newtons minus ma. What is m? M is 5 kilograms. What is a? It's not 9.8. It's 6. Oh, 6 meters per second squared. So that's 40 minus 5 times 6 is 30. 40 minus 30 is 10. Boom. Now it wants the, in part B, it wants the coefficient of friction. Well, our basic equation, force of friction equals mu times the normal force. Therefore, mu equals the force of friction divided by the normal force. Well, what is the normal force? Well, if I sum the forces in the y direction, I'll just formally do it. Sum the forces in the y direction equals ma in the y direction. In the y direction, I've only got two forces. The normal force minus the weight equals, and what's the acceleration in the y direction? 0. It's only accelerating in the x direction, not in the y direction. It's not falling up, it's not sinking into the ground. So the normal force is just equal to mg. So the force of friction is 10 newtons divided by 5 kilograms times 9.8 newtons per kilogram. And when you plug in 10 divided by 5 is 2. 2 divided by 9.8 is a little less than 0.2. The answer should be 0.2. So we've got 10 divided by 5 divided by 9.8. And we get 0.204. If you carry it out to 3 significant figures. Okay, so all the steps are, there'll be a problem very similar to this on the test. You see how to do this problem. Read the problem, given, find, and solve. Draw the free body diagram. Identify your XY direction. Sum the forces in the X direction. That allows me to solve for my unknown right away. And then sum the forces in the Y direction. Oh, the normal force is equal to the weight. And then use your friction equation. That is all.